Hey everybody, it's Mr. Carr again. Today we're going to be talking about 10.3 properties of trapezoids and kites. So these are our last two types of quadrilaterals we're going to look at. They're a little bit different from our parallel lines, or our parallelograms, I should say. Okay, so to start, let's talk about what it is a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel lines. Okay, the bases are parallel. So the bases, I would call them like B1 and B2. So it's weird to call something as multiple bases, but that's the parallel lines that are in a trapezoid. So one thing I'm going to show on here is we got this right here. These are parallel, and then these are parallel. That's what makes these both trapezoids. Consecutive interior angles are supplementary. So now it doesn't matter which way you go. So if you look like here, and I should say consecutive interior angles, but also it like needs to be one base angle in each case. So what I mean is that is this angle and this angle are supplementary. Okay. Now there's a special case here for this first one. This is what's called an isosceles trapezoid. So if I've had an isosceles trapezoid, we actually get a special thing here where this is going to be right here. That's these base angles here are going to be congruent to each other, and then these two angles up here are going to be congruent to each other. Okay. So when we look at the consecutive interior angles, we're talking about these, and these are supplementary. But I'm not talking about these, and I'm not talking about these. Those are not supplementary there. When I go here, you can see these two are supplementary. This is just a normal, any old trapezoid here. So those are both 90 degrees. Those are supplementary. These two angles here are also supplementary. So if I say angle C plus angle B equals 180 here, and then angle A plus angle D equals 180. But you notice I'm not saying this way. D and C do not add up to 180. A and B do not add up to 180. Okay, so make sure it's kind of like one at the top, one at the bottom. All right, the other shape we're going to call is what's called a kite. That is a quadrilateral with two pairs of congruent sides, but opposite sides are not congruent. And there's no parallel lines here. So what it means is it looks like this. Those two are congruent, and then those two are congruent. But when you look across, that's not congruent, and that's not congruent either. Okay, so it's two pairs of congruent sides, but it's like they have to be next to each other, not across from each other. All right, diagonals of a kite do some special things. Okay, the diagonals of a kite are perpendicular. That's actually just like our rhombus. So if I draw these in, okay, and we're gonna make that one look better. Okay, the diagonals will cross and they are perpendicular. So remember that happens with rhombuses too. Okay, that's just a little callback. Those are also perpendicular. So just make sure you're aware of that when we start kind of classifying. Perpendicular diagonals also apply to kites and not just a rhombus. Okay, it has to be a parallelogram with perpendicular diagonals to be considered a rhombus then. Opposite angles of a kite, only one pair of opposite angles are congruent, and that's this pair right here. Okay, so this pair or those last two are not the same. So these are my only ones that are congruent right there in that kite shape. Okay, the other two are not congruent to each other or to the original two. Well, you could probably make it, not necessarily, I should say. I bet we could make like these three match up or something like that in a kite, but that's not important. All right, find the measure of angle W. So this is one of our properties of our trapezoid. So one thing to help me with this is to help identify that it is a trapezoid. Because of my right angles here, I know that these lines are both perpendicular to this line, so it has to be parallel lines. So that means 146 in W. Well, for that to work out, the measure of that is going to have to add up to 180. So we got W plus 146 has to equal to 180. Subtract that over, and I get 34 degrees. Okay. GHJK is a kite. Find the length of GH. Okay, so GH is right here. I want to find that length. To help me out with this, I'm going to start with the fact that since these angles Oh, you know what I didn't mention earlier? Okay, I'm going to add to that because that wasn't mentioned earlier. That's not good. In a kite, not only are the diagonals of a kite are perpendicular, um, the short diagonal is bisected. So what that means is this right here is congruent, okay? But these two are not, okay? So we know for like whenever, so with these cross, and again, that's different from a rhombus because in a rhombus, everything bisects each other for the diagonals. But in this case, only one of the diagonals is bisected and the other one is not. So that's important for down here because when we look at this one, we can identify that that's 2. This is also 2. We know that since it's a kite, we know that's a right angle. What we've just created when we look at this, to help me find GH, I got a right triangle now. Okay, so that's what I'm going to go ahead and do. I'm going to pull this aside. Can I do that? There we go. There we go. Let's pull that aside. And I've got 2, 5, and then this is what I want to find the length of, so we'll just call it x. So I can apply now my Pythagorean theorem. 2 squared plus 5 squared is equal to x squared. So we got 4 plus 25 is equal to x squared. 29 is equal to x squared. So we square root that now. So that turns into the square. Well, if I want the exact answer, I'm going to just leave it at the square root of 29. But that is approximately equal to, sorry about that. Here we go. 5.385. Okay. All right. And next example, RSTU is a kite. Find the measure of angle R, measure of angle S, and the measure of angle T. So when I look at this one, the only thing that is applied to our property is the fact that this angle here is also 125 degrees. Okay. So I don't know a whole lot here, but what I do know is this. Okay. Well, I found the measure of angle S. So let me write that down to start. That's 125 because that is the only two angles that are guaranteed to be congruent. Is that one pair of opposite angles. The next thing I'm going to do to find this is use the applications of x with those 4 angles. So we haven't talked about it a whole lot, but you need to remember that quadrilaterals add up to 360. So I can set this up with that kind of an equation. I can do x plus 30 plus we got 2 of the 125s, and that's going to equal to 360 then. All right, so I'm going to go ahead and do this. I've got x and x is 2x plus 30. That's 2 times 125 is 250. So 2x plus 280 equals 360. So I can subtract that over so that 2x is equal to, that'll be 80. Divide by 2, and then x equals 40. Okay, so yeah. Okay, so x equals 40. So that's my angle of T. So the measure of angle T is 40 degrees. Okay, the last one I want to find is R, which is going to be x plus 30. So that means the measure of angle R is going to be 40 plus 30. So the measure of angle R is 70 degrees. All right. Example 4, true or false? In a quadrilateral ABCD, diagonals AC and BD are perpendicular. Therefore, ABCD is a kite. Why or why not? This one's a little bit tough. We just talked about that earlier. AC and BD are perpendicular. It could be a kite, or it could be a rhombus. I'm going to say false in this case. If I had to say use true or false, I'm going to say false. And the reason why not is it could be a kite or rhombus, okay, depending on more information. Okay, so that's what we would want to look for on there. All right, so I got some you try now problems. I'm going to let you try them out. Give it a shot. Remember those properties. So we got we got the trapezoids. Like trapezoids have supplementary angles that are consecutive. If it's an isosceles trapezoid, which I don't have here necessarily, then these are going to match up and then these are going to match up. But I'm going to focus more on the supplementary angles. Then we have kites, where they have perpendicular diagonals to each other. And they also have this where two pairs of congruent sides, but they're not congruent across from each other. Okay. We also have angles that are going to be equal here and here, as well as, let's go 3 there. Okay. As well as one of the diagonals being bisected. Okay. All right. That's it for 10.3. Considering your work, that's it for this unit. So take care, everybody.